Welcome. My name is Utkarsh Opalkar and I will be presenting the second half of this SDS. Let's talk about system architecture. The manner in which the different components of a software model are designed is called its system architecture. For semantic caching model, we see that there are two major components or as such for our software, which are the server side and the client side. So architecture in both these parts of the software must be perfected in order to achieve maximum potential out of the software. So first let's talk about the server. The server is responsible for handling numerous user accounts. It should provide access to them, as in which client should can access which level of data, which can it interact with other users, and all such other information, other such processes are handled by the server. So we must keep in mind all these processes while designing the architecture. The server should have power over all other clients. Then we move on to clients. Talking about clients with in the perspective of system architecture, we see that these clients should be able to interact with each other through the same network in which they are connected to the server. So the clients should be able to request for queries to be processed by the server, as well as it should be able to access other clients' cache memories and search those memories for results for their own queries. So the system should be able to accommodate numerous clients at the same time. So that's about the system architecture. Moving on, here's a small diagram this which depicts the system architecture. It's a very basic diagram. It doesn't have any detailed information, just a simple block diagram which shows two clients, and we can connect many such n number of clients. Each of these clients will have their own cache memories, and each of these clients can also interact with each other. Plus, most importantly, all these clients will be connected to the server directly through the network. So the server can monitor the activities of each client, like when they log in, when they log out, what queries are they asking for. The server should also be able to process the queries put forward by these clients individually, and all such other processes. That is why system architecture plays such a key role when it comes to software design specification. Moving on, coming to detailed system design. Me and my partner, we thought that the system design can be explained in detail with help of just one single use case diagram instead of using a lot of words and just simple text. So we see that this use case diagram can explain the system design because it shows all the actors involved, all the sub actors like clients, their cache memories. Each of these clients can have sub clients depending upon the role of the software. Then on the server side, we have the server itself, a server administrator, a database administrator who manages the database and its metadata. So all such components are clearly visible in the use case diagram. So all these clients who have their own cache memories where results of previous queries are stored, all these clients are connected to a single network, a common network, which then connects all these clients to the server. So that's about it. And moving on to the processes, use cases. Database access must be provided to the clients depending upon what they are requesting for, what their queries are. So that depends on database access. Server time allots a time slice for processing queries of each client individually. Cache sharing and cache searching are operations that are required on the client side itself. Like one client should be able to search or share its cache memory with other clients. So these two processes are on the client side itself. Query processing is a process which takes place between the client and the server only. So when a client does not find the result to its query anywhere on the client side, let's say its own cache or cache of some other clients, it will post the query to the server. The server will acknowledge it, and it will process that query, generate a result, and send the result back to the client. So this is how our system will work. This is the design of our system, so to speak. Moving on, glossary. We have used certain terminologies, some abbreviations throughout our documentation and our presentation. So let's have a look at them. SDS. It stands for Software Design Specification or Software Design Description. Graphical User Interface (GUI). DBA, Database Administrator; DBMS, Database Management Systems; UML, Unified Modeling Language, which is basically process, depicting your system through diagrams, different diagrams, state diagram, sequence diagram. Finally, we have SRS, Software Requirement Specification. So we have reached the conclusion of this presentation. And I would like to conclude by saying that the system that we have developed helps in making a server client system much more efficient than it already is. So as we know that there are vast applications of server client systems, and making them faster will definitely help both the server side as well as the client side. It will increase the processing speed of the system, definitely, because since the queries that are posed by the clients are either processed on the client side itself or and are rarely sent to the server, so the server is free to do other processes, other more important processes, and it is not kept busy with minor some simple queries. Then the software also organizes the cache memory and searched queries. This means that it stores all the previous queries and the results of those in a cache memory, so that if the query is posed again, all the transactions and all the processing may not be done again and again. It can just retrieve the answer from its cache memory itself. Then essential model for application like database, transaction, and search engines. So this is just an example of where our semantic caching model can be applied in the real world. Like search engines can benefit gravely from our model, from our software. And lastly, since it is an incremental model and its cost, it doesn't take up much cost, and every time the client makes a query, it keeps adding to its own cache. So that is how it is an incremental model, and it can just be added on to any existing server client system. So setup is very cheap, and that is what makes our semantic caching software so powerful. We have mentioned only a few references because we didn't have enough space. Thank you.